Hey, welcome back. This is Mr. Bean. We're going to have a review video here as we briefly go over some of the things we've learned in this unit on polynomials. This is not a comprehensive review. It's just to kind of get your feet wet a little bit on remembering some of the things that you have been doing. So let's start off with the first lesson dealing with operations on polynomials. I'm not going to remind you how to do all the adding and subtracting. Our focus here is just on going to be a little bit on the factoring and solving, but also remembering what in the world the degree and leading coefficient is. So to be able to recognize the degree and leading coefficient, you have to find the variable with the largest power. The largest power is the degree of the polynomial. And then the leading coefficient is the coefficient of that term. So it's -7. Simplifying, I'm not going to multiply this whole thing out, but just remember, I've put one on here that is probably a little bit more trickier for kids, and that is that when you see this squared here, this part right there, that means there's two of them. So don't forget to write it out and then multiply through. And then here are the negative distributes, if you wanted to keep writing out this next line a little bit here. Okay, so just don't forget that. That's a common mistake that kids will make on these. Here we're going to factor completely. So the first key to factoring is look to see what they all have in common. So I can see each of these numbers is divisible by 3. So I'm going to write a 3 on the outside, and then what am I left with? 3x to the 6th minus x cubed minus a 30. Okay, from here, now this is where we need to factor it, and there's several ways, depending on how you've learned it in the past, that you could be able to do this. What we really want to get to is, I'm going to write what we're trying to find. X to the 6th at the beginning, x cubed in the middle, and there's no x at the end. That means we're going to have x cubed and x cubed here and here. If you multiply those, you're going to get x to the 6th. And then we need one of these to be a 3 and one of them to be a 1. So this is just a 1 right there. That multiplies to 3, and then we've got to multiply to -30 as well. So this takes a little bit of guess and check. So this is eventually what we're going to get, or what we're trying to work for. If you can't do it this way, you might have problems doing it like that. So how about this? If we just rewrite the 3x to the 6th in front, and then write the -30 at the end, then we're going to split up this term here. So we're going to, let me go off to the side here, we're going to multiply to -30, and we're going to, oh, not -30, we're going to multiply to, fix that, 3 times -30. Remember, it's the front and the last. So the front term and the last term is -90. So we multiply to -90 and add up to a -1. So numbers that multiply to -90 and add up to a -1, that is going to be -10 x cubed and a +9 x cubed. So you just take this middle term, whatever it's x cubed, that's going to go here and here. And now you can do some factor by grouping, and that 3 still has to stay in front. Okay, so what do these first two terms have in common? It looks like just an x cubed. So let's pull out an x cubed, and we'll be left with 3x cubed minus 10, close parentheses, plus, what do these two have in common? I think it's just a 3. So 3. And then I'm left with 3x cubed minus 10. Okay, there's a lot of parentheses going on here. And again, if you could have just seen it and gone straight to the answer, you can do so. I'm showing how to do it by factor by grouping, because then you can double check as you're going through this whole process that you didn't leave anything out. So we've got 3, and then let's take out this 3x cubed minus 10. And then what are we left with? The x cubed plus 3. And there's our factors. Next up, we're going to solve an equation. Now, when we solve these things, basically you just want to get everything onto one side. So we're going to bring this there, the -2x squared, we'll subtract that over. Then we get a plus x, and then a -2, then equals 0. The whole point is to make sure that it equals a 0 so we can use the zero product property. The zero product property only works if it equals a 0. If it equals anything else, you can't use this thing. So now we have this thing with 4 terms on the left side. So one of our strategies is factor by grouping. So let's take a look at the first 2 terms here, and they both have an x squared. So I'm going to pull an x squared out from those, and then I'm left with an x minus 2. Okay, next one. Do I have anything that these have in common? No, I don't. So really, if they don't have anything in common, I'm just going to say I'm pulling out the number 1, and then have x minus 2 equals 0. And since we have x minus 2, since those are the same, that was perfect. We can now pull that to the front and just say x minus 2 times x squared plus 1 equals 0. And now we're going to solve. We're going to solve this one here, x minus 2 equals 0, and x squared plus 1 equals 0. Once you have things factored that equal 0, you just separate each individual factor and solve it. So there's one answer, x equals 2. And then when we get x squared equals negative 1, and then you take the square root of that, you'll get x equals plus or minus, because we're taking the square root of both sides, and then the square root of negative 1 is just an I. All right, that's how we solve using factoring. Now let's look at our second lesson, which was a few things going on here. We're going to list all of the possible zeros. In order to know all the zeros, we need to find all the factors. Factors and zeros have a lot in common. So this first one is that I gave you a 0 here, negative 3. So we can do synthetic division. 1, 3, negative 1, negative 3, negative 2, and negative 6. Let's make sure we didn't miss a term here. 5, 4, 3, 2, 1, 0. I'm just counting to make sure I didn't miss any terms. So now we're going to set up and use synthetic division. A minus 3. The 0 goes on the outside. We don't put anything right there, so the 1 just comes straight down. Negative 3, 0, 0. Now, I'm not going to reteach how to do synthetic substitution or synthetic division, so if you don't know what in the world I'm doing here, you're going to need to go back and look at the second lesson. 0, 0, negative 2, 6, 0. Perfect. And if this last one is not a 0, then we messed up, because it said right here that it equal to 0, meaning there has to be no remainder when we divide this. So now we have, let's write this out, x to the, that used to be to the 5th, so now it's x to the 4th. And then, so this is x to the 4th, this is x cubed, x squared, and so forth. So there's no x cubed term, but we do have an x squared term. There's no x term, but there is a constant, minus 2. So now we're going to find out when will this thing equal 0. So we factor it, equals 0. We're going to have an x squared term at the beginning of each parentheses, each factor, and multiply to negative 2, add to negative 1. That's a minus 2 and a positive 1. So what are the zeros? We just keep solving. So set this equal to 0 and solve. We'll get x squared equals 2, or x equals plus or minus the square root of 2. And then this one here, we'll get x squared equals negative 1. Take the square root of both sides. X equals plus or minus I. And there we go. There's all the zeros. And if we could also list negative 3, because negative 3, I guess is also a 0 from the beginning, which we gave it. But these are the new ones that we're looking for. Okay, next one, we're going to figure out, is 4x minus 1 a factor of this? Well, how do you know if something's a factor? If you divide into it, you get a remainder of 0. If we can get a remainder 0, then it is a factor. So there's a few ways of doing this. You could do long division, or you could do synthetic division. Synthetic division is a little tricky because when you're done with synthetic, you have to divide everything by a 4. So you'd use 1/4 on the outside of this thing, and it would work. It's just whatever your answers are here, you divide them by 4. But we only care about if it has a remainder or not. Now, because I don't have anywhere else on this review video where we're practicing long division, I'm going to set up long division here. And then I double check to make sure, do I have placeholders for all of my terms? X and then a constant, third power, second power, first power, and then no variable. So it works. All right, so I'm going to go 4x goes into 4x cubed. 4x goes into 4x cubed, x squared times. Remember, I'm only trying to figure out if it's a factor, so I'm looking for the 0 at the end if I have a remainder. All right, x squared times 4x is 4x cubed, and then x squared times a negative 1 is a minus x squared, and then I'm going to be subtracting this entire line. So subtract that whole line, and I get, this is gone, 3x squared minus a negative means plus, so 4x squared minus 5x plus a 1. Start over. 4x goes into x squared, x times, and then 4x squared. X times negative 1 is negative x. Subtract that entire line. And that cancels. Negative 5x plus an x is a negative 4x plus 1. And then 4x goes into negative 4x, a minus 1 time. So then we go negative 1 times negative 4x is a negative 4x. Negative 1 times a negative 1 is a positive 1. And then when we subtract that entire line, subtract it, these both cancel, and we're left with a remainder of 0. So therefore, since the remainder is 0, whoop, yes, this is a factor. But you can't just go 50-50 guess, say yes or no. You have to show your work and show that there is no remainder. Now, if I could have used synthetic, that probably would have been a little faster if you know how to do it with the 4 there. All right, on to our third lesson now on the polynomial graphs. So we've got a portion of f of x that's shown. We're going to use the graph to determine one 0, and then find the exact values of all the other zeros. So we only have one little portion of the graph being shown. There's more things going on. So let's figure out what this is. 1, 2, 3, right there, 4. So I know that x equals 4 is going to be a 0. So we can use synthetic division. Let's write this thing out. 2, 5, what else? Negative 74, negative 55, and 572. That's really, really sloppy. And I'll put a 4 on the outside here. Let's clean that up. All right, synthetic. Here we go. 2 comes down. 4 times 2 is 8. 13. 4 times 13 is, oh man, 52. Negative 74 plus 52. Negative 22. 4 times negative 22 is negative 88. Add these up, we get negative 143. Multiply 4 times 143, and you get 572. Negative 572. Now, how do I know that so fast? Because I have a calculator outside here that you can't see. All right, these go. Add these up, we get a 0. Perfect. It had to be a 0, or else we would have chose the wrong number over here. Okay, so now we have, this is 2x cubed plus 13x squared minus 22x minus 143, and well, we're going to say that it equals a 0. We're trying to solve this thing for all the other zeros. So 4 terms, probably factor by grouping. I really hope it is on this one. Let's pull out the first 2, see what they have in common. We've got x squared, and then what are we left with? 2x plus 13. And then over here, we want this to be, whatever we take out, we want what's left to be 2x plus 3. So my guess is we're going to take out a negative 11, because that makes this a 2x. Now let's just hope that 143 divided by 11 is 13. Yes, it worked. 13. 2x plus 13. I took out the negative, that's why it's plus. Equals 0. So now we have 2x plus 13 times x squared minus 11 equals 0. And when you solve these things, you're going to get x equals negative 13 halves, or a plus or minus the square root of 11 when you solve both sides of those. All right, now let's list the number of positive real zeros and negative real zeros. So to list the possible number of zeros for both positive and negative, we need to also figure out h of negative x. So if we plug in a negative here, and it's a power 3, that just becomes negative 7x cubed. And here, it's going to be a minus 12x. And then here, there's nowhere to plug it into it, so it just stays minus 1. So now let's count the number of times it changes for the positive one. Positive sign, negative sign. So it changed one time. So there are either going to be 1 positive zeros or 0. So I guess we could say it like that. We could say 1 or 0 positive zeros. I mean, it's going to cross the x-axis once or no times. This one. Well, how about this one? How many times will it have a negative 0? It's going to change signs negative to negative, negative to negative. It never changes signs. So there is going to be no negative zeros for sure. There are no negative zeros. So that's how we do that one. You just count the number of times the sign changes. And then our last example, we're going to sketch a graph of this thing. We have negative 5, 0. So 1, 2, 3, 4, 5. Negative 5, 0 right there. And we know that it's 4 is going up, so it's going up on this side. I like to sketch that part of it. And we know it's going up on this side because it's even and it's positive. The degree is even and the leading coefficient is positive. So it's got to be going up and up. Okay, what else can we get? Well, let's divide all this stuff out. So if I have negative 5 and then have my synthetic division, 3, 14, negative 80, negative 350, and 125. So nothing there. 3 comes down. Negative 15, negative 1, 5, negative 75. 75 times 5 is going to be 375, and it is positive because of the negative and negative. Add those together, you get 25. And then negative 5 times 25 is negative 125. So we'll have a 0 at the end, which it should be. If we didn't get a 0, then we messed up somewhere. Okay, so then we have 3x cubed minus x squared minus 75x plus 25. So now we're going to continue to factor this thing. And, well, this is another factor by grouping. I did not mean to give you so many of those. X squared times 3x minus 1, and then what can we pull out here? A negative 25. What's left? A 3x minus 1. So here's our factors. We have 3x minus 1. We have x squared minus 25. And we had originally an x plus 5. The x plus 5 comes from the negative 5 as a 0. Well, this thing can still factor, and so we actually have to go one more line. X minus 5. This is the difference of squares, so it's x minus 5 times x plus 5. And then we still have that other x plus 5. So this one right here, since there's 2 of them for the multiplicity, there's 2 of them, it represents that it is tangent. It's tangent at this negative 5, 0. So right here, we know it has to be going like this. And then, oh man, I just realized that was stupid. Okay, sorry. Some of you probably caught this. Negative 5, 1, 2, 3, 4, 5. That's a negative 5. I should probably pay attention to what I wrote there. And then we have tangent. And where's the other zeros? 5, 1, 2, 3, 4, 5. Now that 5 is supposed to actually be in that one. And then 1/3 about there. These all have odd multiplicity, so it's going to be crossing, crossing, and then you just fill in the rest. The rest of it doesn't really matter. You're just kind of filling in. However far down we go, it doesn't really matter. This is just a sketch of the basic. We're looking for the zeros and the end behavior, making sure that it's either crossing it or tangent. And that is it. Good luck on that test. I will not see you back until the next semester, which some of you are probably so relieved. And you're going to have, how many lessons, Brust? How many lessons you're going to have, units between now and 1? 2 units. I'm so sorry. I will see you in quarter 3.